You're standing on a spinning ball, hurtling through the cosmos. Yet here you are perfectly still, not drifting away, not floating off into the endless void. It's a mundane miracle we rarely consider, this invisible force that keeps us grounded. But what exactly is this force, and how does it manage to hold down everything from the oceans to the tallest mountains? For millennia, humans simply accepted that things fell down. Aristotle believed objects sought their natural place. It wasn't until a certain apple fell, or so the story goes, that we began to grasp the true nature of this invisible tether. This wasn't just about things falling, it was about an attraction. Isaac Newton, in the late 17th century, gave it a name: gravity. He didn't invent gravity, of course, but he was the first to mathematically describe its universal pull. His radical idea was that the same force making an apple fall also kept the moon in orbit around the Earth, and the Earth around the sun. Newton's law of universal gravitation stated that every particle of matter in the universe attracts every other particle with a force directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. It sounds complex, but it boils down to two key ideas. First, the more stuff something has its mass, the stronger its gravitational pull. A bowling ball pulls on you more than a feather does, though you wouldn't feel either. Second, the closer two things are, the stronger the pull. Move them farther apart, and that pull weakens dramatically. Think of it this way: your coffee mug has a tiny gravitational pull on you right now, but you don't notice it. Why? Because the Earth, with its immense mass of 972 times 1024 kilograms, is pulling on you with an incomparably stronger force. It utterly dwarfs the mug's feeble attraction. This immense mass is the first reason we don't float off. The Earth acts like a giant, invisible magnet, constantly pulling us towards its center. Every atom in your body is being pulled downwards, and every atom in the Earth is pulling back. But it's not just the Earth's mass. There's another player in this cosmic tug-of-war: inertia. An object in motion tends to stay in motion, and an object at rest tends to stay at rest, unless acted upon by an external force. This is Newton's first law. The Earth is spinning, completing a full rotation approximately every 24 hours. At the equator, you're moving at over 1,000 miles per hour. That's incredibly fast. So why aren't you flung off like mud from a spinning bicycle wheel? This is where the balance between gravity and centrifugal force comes in. Centrifugal force is the apparent outward force experienced by an object moving in a circle. Think about spinning a bucket of water over your head. The water stays in. On Earth, the centrifugal force trying to push you outwards is incredibly small compared to the gravitational force pulling you downwards. Gravity wins every single time. It's like a gentle nudge versus a powerful bear hug. At the equator, the outward centrifugal force is strongest, making you feel slightly lighter than you would at the poles. It's a subtle difference, less than 0.3% of your body weight, but it's measurable. So, technically, you are a tiny bit closer to floating at the equator. But even if you could somehow negate Earth's gravity, you still wouldn't just float off into space instantly. You'd need to overcome Earth's escape velocity, which is roughly 25,000 miles per hour, or 11.2 kilometers per second. That's the speed an object needs to reach to break free from Earth's gravitational pull and not fall back down. Rockets achieve this by burning massive amounts of fuel, generating enormous thrust. You, standing still, have nowhere near that velocity. So it's a combination of overwhelming gravitational pull from a massive Earth, coupled with our relatively slow rotational speed, that keeps us firmly planted. It's a delicate, yet incredibly robust cosmic dance of forces. But gravity isn't just about holding us down. It shapes our entire world. It's why planets are spherical. Gravity pulls everything towards a central point, smoothing out irregularities. It's why rivers flow downhill and why mountains don't grow infinitely tall. Even the air we breathe, our atmosphere, is held captive by gravity. Without it, our precious oxygen and nitrogen would simply dissipate into space. Our very existence, our ability to breathe and thrive, is a testament to this invisible force. And the story doesn't end with Newton. Albert Einstein, in the early 20th century, revolutionized our understanding of gravity with his theory of general relativity. He proposed that gravity isn't a force in the traditional sense, but rather a curvature of space-time itself. Imagine a bowling ball placed on a stretched rubber sheet. It creates a dip. Now roll a marble nearby, and it will curve towards the bowling ball, not because the bowling ball is pulling it, but because the sheet itself is curved. That's Einstein's gravity. Massive objects like planets and stars warp the fabric of spacetime around them. We, and everything else, simply follow these curves. This elegant explanation accounts for phenomena Newton's theory couldn't, like the slight bending of starlight around the sun. So whether you view it as a universal attraction or a warp in spacetime, the outcome is the same. We are firmly anchored to our planet. It's a constant, unwavering presence, silently orchestrating the cosmos, from the smallest raindrop to the grandest galaxy. Next time you feel the solid ground beneath your feet, take a moment to appreciate this invisible force. It's not just holding you down, it's shaping planets, guiding stars, and making life as we know it possible. It truly is the fabric of our existence. We often take the most fundamental aspects of our world for granted, like why we don't float off into space. But when we look closer, we find layers of fascinating physics, revealing a universe far more intricate and wondrous than we first imagined. From the apple falling from a tree to the intricate dance of galaxies, gravity is the silent architect, ensuring that everything stays exactly where it should be. It's the ultimate invisible hand, guiding the very architecture of reality. What other obvious phenomena hide surprising scientific secrets?